This is a magma chamber model that I made earlier this summer. I'm sticking a crystal into the container that you can see is filled with a liquid, and it's kind of old and it's taken a bit of resetting to get it back to being functional, but in a second here I'm going to move it around and it'll start crystallizing. And this is the simulation that we're going to have for your lab to model a magma chamber cooling into a Pluton. So how are we going to make this? This is sodium acetate, and we can make it at home very easily with vinegar, baking soda, and some patience. But no precision needed, which is important because you're going to see here in this video how you can mess it up for the second time and still make it work. So this first model that I'm showing you here, I accidentally made almost exactly the same way as the one that I'll show you here. So we're going to start off with a big pot on the stove. The stove is off, and you're going to use just plain white vinegar. This says it's 5% acetic acid. It's just the cheapest stuff from the grocery store. And we're going to put a liter in the pot. So once you have that, you can turn the stove on gently. You don't want to bring it up to a boil right away or anything, or you can wait until you've stirred in the baking soda to bring it up to a boil. So just regular baking soda. Here we're going to add in 4 tablespoons, really carefully, slowly. I'm going to dump the first one in. You can see it immediately kind of blows up there. This is your elementary school volcano that's happening. So you want to kind of add the remaining 3 tablespoons in pretty slowly to make sure that you don't overflow your pot and make a mess everywhere. So I'm going to just do that. And then once you've got all your baking soda completely into the solution, then you can go ahead and crank the heat. So you're going to want to make sure you mix this in pretty well. And now what we've done by adding the acetic acid or the vinegar and the baking soda together, you've got a chemical reaction, as you can see here, and you have carbon dioxide, that's the bubbling gas being emitted. So don't breathe that in too deeply or at all. Please don't breathe that in. Just don't breathe that in. And the remaining solution is a very dilute sodium acetate. So the reason we're boiling it down is to concentrate it to a supersaturated sodium acetate, which is what our magma chamber analog model is going to be composed of. Alright, so now I've got it all dissolved in, and I'm turning on the stove and I'm going to let this boil away. So as this is boiling down, all the instructions everywhere that tell you how to make sodium acetate will tell you that you can boil it quickly or you can boil it slowly, and the difference is going to be the clarity of the crystals. You probably noticed that my solution was brown that I showed you, and that was because when I was boiling it in the first time, I forgot that it was on the stove and I boiled all the liquid away into crystals. I should note that the first time that I boiled this down, I kept it on a slow, gentle simmer with the intention of trying to get the clearest crystals possible. Unfortunately, I completely forgot about it the first time. So the second time I just said, whatever, let's just boil it high. I don't really care what color the crystals are. So here you can see it's a rapid boil. It literally boiled for 20 minutes. At this point, I went and I put my camera down and I turned around, and it was already, you'll see in 2 seconds here, it was already completely gone and back to solid crystals. So 20 minutes, full boiling, and you can see I'm now scraping the pot of all of the sodium acetate crystals. So much for doing this correctly the second time, but this is for troubleshooting, so probably this will happen to you as well. So I'm going to scrape all these crystals out and put them in a bowl. I saw that you can use alcohol to clean the crystals, and I should let you know not to do this. So here I'm doing this. First of all, you're boiling vinegar and baking soda for 20 minutes, and that smells pretty terrible unless you really like the smell of boiling vinegar, which I don't. But now I'm trying to wash these crystals, which have cooled down, with alcohol, and that alcohol volatilizes and kind of reconstitutes the amazing vinegar smell So now I'm smelling hot alcohol and vinegar, and it's absolutely disgusting. And the crystals are barely coming clean, probably because you're supposed to wash it when there's still liquid in there, which I didn't have. So this is a step you should absolutely skip if you decide to venture onto YouTube for references on how to make your sodium acetate. Avoid the alcohol washing. So here's my clean crystals. They're still yellow. They're not very clean, and it smells absolutely awful. So now I have to actually turn this back into a solution, and this is where some fiddling is necessary. So here you can see I'm measuring with a tablespoon again. I don't know why I bothered measuring. So I measured in 2 tablespoons of water, microwaved it. You can see I'm stirring it in and mashing down the crystals, and it's still pretty cloudy. So I microwaved it again, and I got all those crystals pretty well dissolved in there. So now you want to let it cool until it's room temperature, and for me it was insufficient. So I ended up adding about 4 tablespoons of vinegar back in, continuing to microwave it, stir it in, let it cool down, and then eventually, after those 4 tablespoons were in there, you can see it works perfectly, and we have our crystallizing sodium acetate. What's generating the start of this crystallization is a crystal I saved from that original pot of crystals that I scraped down. And you don't necessarily need to use that. You should just be able to use a toothpick, but save some crystals just in case for a backup plan. So the moral of this story is, if you mess it up, you can still save it, and vinegar and microwaving is kind of the key. When you do this lab, I want you to make some critical observations. What kind of chemical reaction is this? Think about how this chemical reaction in this analog model can relate to the rock cycle and the emplacement of magma chambers in the Earth's crust. The other neat thing is you can reuse this over and over again. You're just going to screw a lid on tightly, and you can reheat it in a water bath. That crystallized material will melt back down into a supersaturated liquid that you can nucleate again with either a crystal or a toothpick.